During the last rainy season, we neglected our site out in the Oregon Coast Range. We were having electronics problems and so didn't have our instruments on and weren't there much of the year until April of 2016. We got out there for a field trip and saw what had happened over the last water year. There'd been a lot of bank erosion and our Picohydro system was, well, it wasn't busted, but it was a little beat up. I didn't get a good picture of the pond that we made for the intake for the Picohydro system until the end of September of 2016. And it's amazing that there was any water flowing at all, given that the pond was completely filled in and the intakes were completely covered with sediment.
Here's the pond. This is after a few days since it was last cleaned out, I think.
In contrast, here's some older video from January 2015 showing the intake pond with the intake pipes. The creek itself had some major changes. You can see here the bank had eroded quite a bit at the outlet of the small stream where our hydro system was sitting. And here you can see an antenna was ripped free where it was anchored to bedrock. The wires leading to the tuning box were simply bare. So the current took away the antenna, it took away the tuner, and left wires behind.
I'll let you think of a reason why we should or shouldn't. Why continue to disconnect these?
John's just using a regular set of very good diagonal cutting pliers to cut off these PEX rings. There's probably a specialized tool to do that, but we don't have it. So far the diagonal cutting pliers seem to be working just fine. So the more water coming out of the jets, the more power you've got, but the greater the diameter of the jet, the lower the velocity and the lower the efficiency in terms of kinetic energy per potential energy. Also, this time of year we're relatively low on water, so we might want to crank those jets down a bit. Still, it's fun to see them sort of going full blast right now. And once the rain comes, we'll have plenty of power. So here we got our jets going, turbines cranking. I think this one, the one that's still on right now, does not have a load on it. It seemed to be spinning faster than the other, but we also noticed the other had some wobble and perhaps some rubbing sound. I don't know, some uneven sound it was making and a bit of wobble to the rotation on the turbine. We have one newer alternator which has a stainless steel shaft, axle, whatever, and an older one that has the cheaper axle, non-stainless steel. We're speculating that right now we're looking at the one that's the newer, better alternator, and that the one with the wobble, you know, seems like that kind of wobble is just down to an axle that's not perfectly straight. These got knocked around a bit over the winter, so maybe once you start talking about replacing the axle, you might as well buy a new alternator, because the axle is connected directly to the magnets, so you got to replace that whole thing. That's like $200, whereas the full-on alternator is $250. So yeah, we can live with a little wobble. What it'll do is that it'll mean that the jets aren't hitting perfectly on center for the full rotation. But it's probably good enough to provide us power. It'll just be less efficient than the other one. I just turned on the other generator. We had to get this pipe wrench because one of the handles broke off of the valve handle there, or off the valve. So we got a pipe wrench so we can just torque on this bit itself. It just gets really stiff, especially under pressure. So now we got both going. That one is clearly going slower, I think, than the other. Still. But now they're both under load. It may be worth my while to wait a little bit and see whether this amount of flow can be sustained today. If it's too much flow, if it's more flow than we're getting, then the level in the little pond up the hill will fall and expose the intake pipes, and we'll start getting a rattling sound in the pipes as air bubbles make their way through. I can narrow the apertures on the jets to get less flow. It'll also make the flow faster, so I won't lose power in direct proportion. I'll lose less power than the amount by which I reduce the diameter of the pipes, if that makes sense. Because the narrower the opening, the faster the jet.